Part 5. Finding all complex zeros of polynomial functions. Use the remainder theorem to identify two rational zeros of the polynomial f of x equals 3x to the fourth minus 22x to the third plus 55x squared minus 46x plus 10. Here's a list of the possible rational zeros, and if I try a bunch of these, I do get f of 1 equals 0, and f of 1/3 also equals 0. You could verify that on your own, or verify that the others here are not zeros. So two rational zeros are 1 and 1/3, because f of 1 equals 0 and f of 1/3 equals 0. Let's find the rest of the zeros. So with same polynomial here, we're going to use the zeros 1 and 1/3 to start with, and then find the other zeros. So I'm going to do synthetic division. I know 1 is a 0, so I'll start with 1. My coefficients are 3, negative 22, 55, negative 46, and 10. Bring down the 3. 1 times 3 is 3. Add, we get negative 19. 1 times negative 19 is negative 19. Add, we get 36. 1 times 36 is 36. Add, we get negative 10. And 1 times negative 10 is negative 10. Add, we get 0. So I knew 0 would be the remainder here. We'd have 0 as a remainder. I also know 1/3 is a 0 of the function. So I'm going to use the coefficients that I got at the end of my synthetic division with 1/3. So bring down the 3. 1/3 times 3 is 1. Add, we get negative 18. 1/3 times negative 18 is negative 6. And 1/3 times 30 is 10. And we have our remainder 0. So we started with x to the fourth. And we did synthetic division with 2 of the zeros. So now we're down to x squared. So I have 3x squared minus 18x plus 30. And I need to find the zeros of that. I can factor out a 3 here, just so I have smaller numbers to work with. It always is nice to have smaller numbers. And this does not factor, so I am going to use the quadratic formula to find my other zeros. So x equals negative b, so negative negative 6 is 6, plus or minus the square root of b squared, minus 4 times 1 times 10, all over 2 times 1. Simplifying that, I get 6 plus or minus the square root of negative 4 over 2, which is 6 plus or minus 2i over 2. And everything there is divisible by 2, so I get 3 plus or minus I. So the four zeros are 1, 1/3, 3 plus I, and 3 minus I.